Hi, in this video we'll go over software quality. So the topics that we will look at is what is quality, what comprises software quality. We'll look at different methods in which quality can be obtained. So we'll look at defect removal methods such as testing, design and code reviews and inspections. We'll briefly talk about each of these, and then we'll also talk about defect prevention. So there's two aspects here. One is writing the software in such a manner that defects are prevented upfront right from the beginning. Defects are not introduced. So how can we do that? And then the next thing is defect removal. So once the code has been written and it's up and running, if defects are found, then how do we remove them? So those are the two aspects that we'll be looking at. But first we'll start with what is quality. What does software quality mean? So basically it is, are we meeting the user's needs? Is the software meeting the user's needs? That's what we are mainly concerned about. And typically it's very hard to completely understand the true functional needs. But then based on our understanding from the requirements, whatever those needs are, we want to make sure those are met. And here it's the needs and not the wants of the user. So basically there's a hierarchy of these needs. The first and foremost thing is to do the required tasks correctly. Once that's done, then we want to make sure that the performance requirements are met, so those tasks are in fact being executed in a timely manner and in an effective way. The next thing is that the functionality should be usable and convenient. It should be easy to use for the users. It should be economical and timely, and then overall the software should be dependable and reliable. So here's the hierarchy, with the functionality or the required tasks working correctly being the most important, followed by the performance, followed by the usability, followed by the economics of it, and then the dependability and reliability of it. So those are the hierarchy of needs. And so from the PSP point of view, quality basically means that the software, for the software to be useful, it must first of all install quickly and easily. It shouldn't be a painful process for the users. The software should always run consistently in the same manner when executed multiple times. It should, all of the typical tasks, the normal tasks, should execute properly, and if any abnormal or exceptional cases happen, those should also be handled properly by the software. So basically our goal is that it should essentially be bug free, and it should not be destructive or do anything unexpected. That's software quality from the PSP perspective. And any defects that are there in the software, they're really not important to the user as long as it's not bothering them, as long as it's not affecting any of their work, their operations, it's not causing inconvenience to the user in terms of both functionality as well as time or money. So basically the defects, if they're found and if they're bothering the users, then that's when it becomes an issue. Now, as per from the PSP perspective, the any software product, basically its quality is dependent on the defect content. We want to keep that defect content as low as possible, and even the low defect content, if it's causing a lot of inconvenience to the user, then that becomes a big deal, and it affects the quality of the software. So we want to make sure that the defect content is as low or as small as possible, and then work on it to remove any of the defects that are in there. Also the idea is that the developers of that defect content, the engineers or the software engineers who worked on that defect content, it's their responsibility to remove their own defects, right, as quickly as possible right from the beginning. If they occur, if they happen, if they're identified, then determine the cause for the defect and then fix it. And then learn from that process and try to prevent those kind of defects in the future. So that's, with PSP, it's always about learning from, reflect on what went wrong and then learn from it and fix it in the future cycle. So if there's a specific type of defect that you're likely to inject very often, it's in your habit, then learn from it and focus on it for the subsequent projects. That's the idea. If you look at the economics of quality, it is pretty expensive. Testing is an expensive task, and typically also you will see that studies have shown, and historically software groups have spent more than 50% of their schedule on testing. They've also spent more than half of their resources on fixing defects. And because of that, and when we get into this defect fixing more, it's very hard to predict when they will finish. It's hard to predict how much time it might take to fix a defect. So that's why we say that the economics of quality is not good. It takes up a lot of time and resources, both in terms of cost and the manpower. So because of that, it's we want to, instead of getting quality of a product out of testing, our goal should be to put a quality product into testing so that the amount of time spent in testing is minimal. So we want to follow proper processes so that defects can be prevented rather than detected and fixed. So testing by itself, testing alone is ineffective. Again, historically we have seen that most of the issues are happening with overload or configuration or hardware failure. But then if you look at this chart, even after hours and hours of testing, and like I said, 50% plus time is spent on testing, in spite of that, only the shaded green area is really the safe region. Even after that, there's a lot of unsafe or insecure region in the code, in the overall software product. That's the reason we say testing alone is ineffective. Appropriate processes need to be used so that we actually have a quality product right from the start that's put into testing. Also, you'll see that to put it in perspective of numbers, say you have a software system with 50,000 lines of code, and with the traditional development methods, if you use the traditional development methods, you'll see that for every 1,000 lines of code that's being tested, typically 25 plus defects are found. So if we consider this 50,000 lines of code that we have, so basically it means that we might end up with 1,250 defects. And the typical rate of fixing a defect is said to be 10 plus hours. So what that means is 12,500 plus programmer hours to test and fix those defects. So that's the kind of economics that I'm talking about. That's the reason we keep saying testing is ineffective, and we want to, right from the beginning, put a quality product into testing. So also, if we compare quality and productivity, so based on these numbers that are needed in order to do testing, you'll see that if we can come up with some managed quality techniques, the productivity can be improved significantly. So based on the numbers that I showed you earlier, say we are spending 50% of our entire project time on testing, and say there's 100 developers working 40 hours a week for 50 weeks, so that's 200,000 hours. So if they're spending 50% of the time on testing, then that's 100,000 hours. But then if we use processes and come up with managed quality, the testing time can be reduced to 20%. And if we can do that, then overall the team productivity can be increased by 60%. And that's what we want to aim for and get to this 20% test time by having a managed quality. So we'll first talk about defect removal methods, and then we'll talk about defect prevention. So some of the common ways in which we find and fix defects are, first of all, the very first thing that we do is compile. During compilation, all the syntax errors are removed. Once that's done, then we do unit testing. We unit test each module that we've just created, unit test it to remove any defects. Then these different units that have been developed and tested, we integrate them and test the integration of those units. And then we do system testing of the overall system. So that's really the testing life cycle, and that's how we do testing at different levels. And then there are team inspections where other team members are inspecting your code and trying to find any issues in the flow or in the logic. Again, we're doing this just through static analysis of code. And then another way it can be done is through personal reviews. So this is where you're desk checking your own code, walking through the logic of the algorithm, because you know what you're trying to achieve. So basically walk through, do a dry run through your code to make sure that it's indeed doing all of the steps that are needed in the algorithm. So basically those are the different ways in which we can find and fix defects, and during this course we will go over the details of unit testing, integration and system testing, and you'll also be doing some reviews. So that's how a lot of defects are removed. So that's one way. Now the personal reviews that I just mentioned is very important. Usually you should do that first before taking it to the team for inspections. This is where you privately review your product, and it is very effective, and a lot of issues can be identified through personal reviews. Now personal reviews doesn't have to be only for code. You can use reviews for at every stage, for requirements, for design, for code, for everything that you're developing. So right from in the requirements phase, when you're understanding the requirements, make sure you review it. Once you have your list of requirements, review it and make sure it looks complete. Similarly, once you design based off that requirements, make sure you review your design to see if all of the requirements are being satisfied, and if there is a proper flow, if you're using other objects or methods, are you using them appropriately? So basically go through and review your design, review your code. So, and then if you are doing unit testing, you review your test cases and make sure you're thorough and you've covered all possible test cases. So you continue to do this personal reviews at every stage in the development life cycle. Defect remove, and again the reason for that we want to do these personal reviews first is because once the defects have been introduced, removing them takes time. It is a significant amount of time. So typically, historically, we've seen that unit tests finds about 2 to 4 defects per hour. So through unit testing, you can find 2 to 4 defects per hour, whereas which means the unit testing can find about 50% of defects. Whereas if you look at code reviews, with code reviews you can find 6 to 10 defects per hour, so it's much higher. And when there are practiced reviewers doing the code reviews, they can find 70% or more of the defects even before compiling or testing the code. So here we're talking about reviewing just the statically the code. We're not running it, we're not executing and doing anything with it, just by reading through the code and walking through the logic. Practice reviewers can find more than 70% or more of the defects. So that's what we mean by, so if these kind of processes are followed, then that's what we mean by creating a quality software right from the beginning and putting a quality product into test. Now in testing, the reason why reviews are more efficient is because in testing we're kind of doing it in the backward in a bottom-up manner, or in a reverse direction, because our goal is to run the system and look for any unusual behavior, and then if unusual behavior is found, then we're going to look into the program to figure out where the problem might be, or what could be causing that kind of behavior. So when it's done in that manner, so we really don't know which part of the code to look at, we've just found unusual behavior. So it takes time to pinpoint the specific unit that's causing that behavior. So that's the reason it takes a lot of time. And if the developers who wrote the units are not around, then it's you're basically, the person who is trying to fix the defect is looking at someone else's code and has to understand it, and it obviously takes a lot of time to figure that out. So whereas on the other hand, with reviews and inspections, what you're doing is you're basically reading through the code and following your own logic. So you know what that expected logic is, and so you're following through that, and then at any point of time, if you find an issue, you know how to fix it right then and there. You're in a better position to fix it. So that's the reason reviews are more efficient. Now, reviews should be done effectively again, otherwise for this whole process to be effective, there should be proper guidelines. You should follow guidelines. There are some checklists and standards, and these checklists can be customized based on your experience, but basically these reviews should be done based on these guidelines, checklists, and standards. It should be done in a systematic way. And reviewing should always be done before compiling or testing. If proper coding standards are used, then it's easier to read through the code, and if it's a consistent coding standard across the team, then when you're looking at others' code, it's easier to understand it. Always there should be a design completeness criteria, so there should be a checklist that one should check against to make sure that the design is complete. It is indeed addressing all of the requirements that were given to you. You measure and improve your review process. It's very important to then, if later on you found that, if you find some issues in the code through the review, then and analyze those and why those happen, and try and improve in the next time you're writing code. Make sure to not introduce those kind of defects, and then customize your checklist as you go. If there are some specific kind of defects that you're more prone to, then you customize your checklist based on that. So there should be specific checklists for, so if you're doing code review and if it's a specific language, then there should be checklists specifically for that language or technology, and you should be able to customize them based on your own defect experience or the type of defects that you're prone to introducing. So again, this checklist will vary. If it's a design review, then it'll be a different kind of checklist. So for design review, another important aspect is that the designs should be produced in such a way that they're reviewable, and again, there should be an explicit strategy of what is it that you're reviewing. And then it should be done according to that strategy. So basically, when we say reviewable design, so there should be a defined context, a precise representation, and a consistent and clear structure. Otherwise, if your team is reviewing the design, they may not if it doesn't have a consistent and clear structure, it's very hard to understand it, and that's where languages like UML come into picture. And if consistently everyone uses UML, and if everyone uses the same kind of tool, then we have a precise representation and structure that everyone already understands. So it's important to use those consistent logical elements. So if following a proper design review strategy, basically the different stages in it would include, you first start out by reviewing against the requirements. There's a list of requirements. We want to ensure that each and every function that's listed in the requirements is addressed in the design. Then you look for the overall program structure and flow. Is the overall flow correct? Are some steps missing or some tasks missing in that flow? Then you look for the logical constructs and their correctness. So say you decide to use a particular data structure. Is that an appropriate data structure? can it completely handle the specific functionality that you're trying to build? Then you look for things like robustness and safety and security. Have those been taken into consideration in the design? And then you check the, you get into more details about the different functions of the methods, and make sure the calls are being done appropriately and properly. So are the appropriate arguments available for the function of the method? Is it returning the appropriate result that can then be passed on to the next function or method? So you basically look for those things, and then finally look for any special variables or parameters or files, and if they're being used correctly or not. So that would be the review strategy. Basically, when I said you have to use a proper review strategy, you basically follow this kind of a list and check off each item on that list. Now, with reviews and inspections, it's always important to respect the, so one thing is doing personal reviews, and then inspections is where it's done by others. And these others could be members of your team or members of another team. Now, it's always important to respect the inspector's time, and what I mean by that is you provide a quality product for inspection. So you do your best first to remove all possible defects through your own personal review, and then provide a quality product for inspection. And the reason for that is otherwise it wastes the time of the inspector, wherein they're trying to then they're finding the simple defects and the obvious ones, and they get distracted with those, and then they might miss the more important ones. So we want to first identify those simple silly ones and remove them before taking it for an inspection, and that way we can have a higher quality inspection and a higher quality product. So that was there's two things, like I said: defect removal once the code has been compiled and it's executing already, so it's done at runtime. And then defect prevention is even before compiling and testing. You're trying to build a quality product with minimal number of defects, so that the time spent in testing can be minimized. Now, even with defect prevention, that's also it takes time. This additional steps of reviews and inspections, but it has to be done so that the amount of time spent in testing can be reduced. And like I said earlier, that's the one that's hard to predict. It's hard to predict how much time it takes to fix a defect when it's found. So again, coming back to the PSP perspective, basically defect prevention is nothing but along with that, to follow a good process and to make improvements, the idea is to continue to gather data about your defects. What type of defects are you prone to introduce? And then improve your design methods, and then do prototyping always first, and then build the full product. So if you follow these simple methods as you're developing your individual small units, then you're likely to introduce fewer defects in the code. So our defect prevention strategies, basically once you start collecting data about defects, then you can set priorities. You can look at the different defect types. What is it? What are the type of defects that you're likely to, that are most frequently found in your code? And then target one or two types at a time. And then so basically this is now for improvement. You target one or two types and see how you can make adjustments to your process and not introduce them. So focus more on them and try to not introduce them in your future code. So and that's how you can basically get better at this process. So it's again PSP shows historically we've seen that it's always a good idea to pick only one or two defect types for your initial action, so that you can and try and get better at it. Don't try too hard with too many things at the same time. Focus on one or two at a time, and that helps in getting better. So to summarize, basically, product quality can be improved by so you know you follow a proper development process, conduct reviews and inspections to remove defects even before you get to testing, and that way once we get to testing we already have a quality product, and then we can focus on some of those more harder to find defects, and our goal is ultimately to spend less time and resources and money on testing, because that in general is an expensive process. The other thing that we looked at is the reviews, design and code reviews. They should be done in a systematic way using checklists and guidelines, so that the quality of your programs can be improved. And then finally, you should always measure your work and then analyze the most common defects that you're introducing, and then try and improve upon it in your future work. Also, the checklists that you use for your review process, they can be customized based on your previous experiences, and customize it. If there's a particular type of defect that you're more prone to introduce, then add that to your checklist and make sure you check for it in your review practices. So and that way our hope is that you will get better at this and better at producing quality software. So that's all I have on software quality. Some of the different defect removal methods that we talked about, we'll look at those in detail in future videos. Thank you.